Hey everyone, and welcome to This Explainer. Today, we're taking the core concepts from Chapter 11 and stepping right outside the traditional classroom. We're going to discover how foundational math concepts aren't just confined to a textbook, they are literally the underlying structural code of our daily environment.
Here is our roadmap for today. 1. Math in the wild. 2. The geometry of circles. 3. Power of place value. 4. The art of estimation. And 5. Your mathematical toolkit.
All right, part 1, math in the wild. We're going to find numbers hidden right in nature and everyday life.
You know, math is literally the secret language of the physical world. It isn't just some arbitrary set of rules you have to memorize for a test. No way. It's a highly practical toolkit for decoding reality. Our goal today is to pull math right off those pages and apply it directly to the structures and shapes you interact with every single day.
Moving to part 2, the geometry of circles. Let's see how we can define shapes using just everyday objects.
Okay, let's walk through a surprisingly fun little spatial activity. Grab a coin. Step 1, just trace a circle right around it. Step 2, mark an X somewhere inside. Step 3, place a tiny dot exactly on the line of the circle itself. And finally, step 4, draw a check mark outside of it. It seems super simple, right? But you've actually just perfectly mapped out absolute spatial boundaries. What you just did defines exact geometric spatial positioning. You've established an area strictly inside a boundary, a precise perimeter resting exactly on the circle, and the vast area completely outside of it. With nothing but a spare coin, you've created a definitive, absolute boundary. Pretty cool, huh?
And we can totally take that basic boundary and scale it up into some really complex patterns. Imagine taking that same coin, moving it just slightly along a curved line and repeatedly drawing circles. The overlapping geometry creates these incredibly intricate designs. It bridges simple geometry directly into art and architecture.
All right, part 3, power of place value. Let's talk about how position literally changes everything. Think about the numbers 35 and 53. It's the exact same two digits, right? A 3 and a 5. But simply swapping their positions completely alters the tangible physical value of the number. That right there is the elegant underlying rule of our Hindu-Arabic number system.
So, place value simply means the value of a digit is decided strictly by its specific position. Whether it's sitting in the ones, the tens, or the hundreds place within a whole number. Well, in our system, a digit's location dictates its true power.
To see how this builds visually in the real world, think about how the number 35 isn't just an abstract concept in your head. It is built from 3 physical chains of 10 beads, our tens, alongside 5 loose individual beads representing our ones. It completely grounds abstract numbers into tangible, graspable quantities.
And the best part? This system seamlessly scales up. Whether the digit 9 sits in the hundreds place, giving us 900, or the digit 4 moves way over to the thousands place to represent 4,000, the foundational logic remains identical. This one single positional rule lets us calculate everything from a handful of beads to, billions.
Okay, part 4, the art of estimation. Time to make some educated guesses in the real world.
So let me ask you this. Have you ever walked past a construction site, looked at a half-built brick wall, and wondered exactly how many bricks it took to build it? I mean, it's a fun guessing game for sure, but it's also one that gets your brain actively engaged in practical problem solving.
When you're facing a half-built wall, you definitely don't have the time to count every single missing brick one by one. But we can use a visible, completed section to logically multiply the height by the length. Doing that instantly gives us a really accurate estimate for the remaining gaps to complete the whole structure.
But can you guess the total count without counting them individually? That's the core challenge in rapid estimation, bypassing that urge to count 1, 2, 3. The secret isn't counting, it's aggressive visual pattern recognition and spotting distinct groups. Think about items that naturally cluster into distinct, uniform groups, like a batch of drying papadums, for instance. Spotting these makes rapid estimation incredibly efficient. You just count the items in one average group, multiply that by the total number of groups, and boom, you've got an accurate mental estimate in seconds.
We can instantly apply this same trick to physical storage. If you know exactly 11 books fit snugly into just one compartment on a shelf, and you see 25 identical compartments, well, you can estimate the total capacity of the entire rack without breaking a sweat. It's just a rapid mental multiplication of 11 by 25.
Finally, part 5, your mathematical toolkit. Let's bring all of this together.
The absolutely crucial takeaway from this explainer is that these aren't just isolated textbook chapters. They actually form a cohesive, cognitive survival kit for the real world. Geometry allows us to define boundaries and creatively map out space. Place value gives us the ultimate cheat code to understand massive numbers simply by glancing at a digit's position. And estimation? That acts as a shortcut, solving real-world quantity problems instantly without the headache of tedious counting.
I want to leave you with a final thought to mull over. Look around your room right now. Seriously, look around. What absolute shapes can you trace? What massive numbers can you conceptualize using place value? And what complex quantities can you estimate right this second? Thank you so much for joining this Chapter 11 explainer. Now go out there and actually use your toolkit.